Yo, yo, yo.
So
You working on anything specific, or you wanna any problem you want to work on specifically?
I'm sorry.
Is there like a problem you want to work on specifically, or
Oh no. How about you?
I have this problem that I was trying to do, but I got like maybe 60% done, and I can catch you up to where I'm at, and then we could try to work on it. I just woke up from a nap. I think I thought of the solution while I was like sleeping, but I don't know if it worked or not.
What happened to I'm not doing any hard problems?
Nah, it's not that bad. Trust. Wait, why are you guest?
Huh?
It says you're like guest join, guest one. It usually says like your name.
Oh.
Are you
Okay.
logged in?
Okay.
I don't. I mean, I want you to get your credit for this hard problem, for this pain we're about to endure. Um, should I delete all this? It works for like the regular test cases, but it fails. So I mean, probably got to rethink the solution.
You said you already thought of a solution, so if you think it adds on to it, I just need to catch up to where you're at.
Okay.
Give me about 5 minutes.
All right. I'll wait for you though. Read the question and let me know. Let me know what you think. I'm gonna put a timer on. I'm gonna give us 45 minutes.
There is boxes inside of boxes. What the heck?
Yeah, it was a bit weird. It took me a little bit to understand the problem.
This is like a very complex game.
Yeah, yeah, definitely. If you like don't submit, but if you run this, it solves all the regular test cases.
I'm getting stuck at understanding. It's just give me.
Are you looking at the code, or is it okay if I change some stuff?
I'm not looking at the code yet. I'm just so you can use it whatever.
Okay. I don't know if I want to delete this or not. It's wrong, so maybe I should just cut my losses. Sure. I'll start at the top. We're not gonna have a heap. We're gonna have a yeah. We're not gonna have a heap.
Okay, I'm ready.
Oh,
So what's your initial thought process of how to solve this?
basically we have a heap, and it's 2D. We sort the first value will be the status of the box, and the second value is the box itself. We have an array to hold the keys. Res is just where we can add our candies to. Ignore this.
Why
This
is
is
it
part
2D or heap?
because we want to prioritize boxes that are openable first. We don't want to pick
And
a locked box
why do we need a 2D for that exactly?
because there's no other way to do that unless you have. Do you have another way to do that?
Oh, oh, continue.
This is for my new solution, so ignore that. I basically we have a max heaps because we want to prioritize the ones first because one means open. So I get the highest number. I say if the status, and I call it stat because status is like taken. And I say if the status is 0, which means locked, and we don't have the key, then we continue because we can't open it. And then I add the candies from this box here because if we get this far, that means we get to add it. And then I say for all the keys that we add, we change their status to 1 because we can open it now. Then I add all those keys to our keys array. So if we have a key, we could pass this part here, which is actually kind of redundant. Maybe I'm not sure. I was doing modifications, and then the contained boxes, we just pushed them onto the heap, but it doesn't work because you could end up picking up the keys before you get to the box, and then you'll never be able to open it.
You can you said because you will get to a key, you'll get to a box before you can open it. Is what you said? Is what you meant to say? What did you say,
Yeah,
Greg?
like we'll get to a box and we'll add it into our heap, but we won't have the key. And then actually push submit. I'm gonna show you which one it fails on. I forgot the exact reason. Something like that. No, this is wrong answer. Okay. So do you see the test case that it fails on? I forgot the exact reason, but it's something about the key doesn't work. It should be test case number 21.
You see?
Oh, okay. Let's see. So we only have initial boxes. We have actually all of the boxes. So we add it to our heap, and we should do box number 0 first because it has a status of 1. We add 1 candy to our thing, and then we go to the keys. We get a key for number 2. We set 2 to open, and then oh yes, that's the problem. We have a key, right? And now it's set to open, but our heap is immutable, so the status of 2 is still closed inside of our heap, if that makes sense.
Yeah.
Yeah, that was the issue.
The status of the box. So we're keeping the status of the box inside the heap.
Yeah. That was because I
Status.
wanted to get the ones that are openable first and then save the ones that we are not unlocked for last. But if we get a key and the status changes, the heap doesn't really change. So the order is messed up. So I think we have to separate them and have. I was thinking just get rid of the heap and have a DQ and have it only have 1 value. Just we're only going to add stuff that's openable. Do you have any ideas on how you do that? My idea was just to have a queue instead of a heap and just do like 1D. So don't link the status and the box together in the same data structure.
Yeah, that I was eventually gonna say that too as well, to be honest, just from the jump. Um, but I'm still trying to understand the problem you get wrong, to be honest. Um, but I do agree that having a queue and a heap is
Wait,
my
what?
initial instinct
Why do we need a heap if we have a queue?
to prioritize which one we want to open first, and then the queue we can use as uh like a cooldown method of like if it's available, then we put it back in the heap. But then I'm still trying to understand, to be honest.
Actually, we have the same similar idea, but I was thinking like we don't really. I was thinking get rid of the heap, and I had this locked set. So every time we get a box that we don't have the key for, we just put it in our lock set, and then once we get the key in the future, we say if key in lock set, add it to the heap. I mean, add it to the queue. So our queue only has stuff that is openable, and our lock boxes are. This is like the cooldown place, the lock box, and it could probably just be a set.
Yeah. I mean, yeah, I don't see the necessary reason to have a heap since we're not trying to get like the minimum of anything or like the maximum of anything. So I guess a heap is not necessary. So I do agree.
Oh, okay.
Um,
This changes pretty much everything inside here. So I'm just gonna. Is it okay if I delete what's in the this whole wow? Because we're gonna be using a key, and we're not gonna be like a lot of stuff will change. Or what do you think?
oh yeah, I'm not stuck to anything.
Okay, I'm gonna get rid of this. Okay, so we're gonna get rid of this too. I think we still need. I think we should make keys a set, right? Because it's O of one look up. Like why not? And you can't have like double keys anyway.
Once again, I am still stuck on understanding the problem. I went back to understanding the problem that you got wrong. So if you want to continue coding, I just want to understand.
What do you understand? So walk me through the problem. Like trace it. I know the code's gone, but just I guess I don't know. Use your like I just think about it out loud. You know?
Yeah, so you have initial boxes of 0, 1, and 2. You go into 0, you see that 0 is open, so you open it. You get candies of 1 in here.
Mhm.
Then you would go next in our queue, which would be a 1.
Wait, no, you missed the keys.
Yeah, and then you grab the keys, but you would add the keys into your queue, which is the key would open up 2, right? So that would be
Yeah.
opened. So
Hmm.
1.
And
And
remember,
then
there's
you
no queue. It's a heap. This is the we got it wrong with the heap. We didn't really try the queue solution yet.
and so you put in 1, so you open up 1 next. Uh, 1 is closed, so you couldn't open it. And so you go on to the next one, which is 2. 2. Why don't we directly change the status? Did you ever directly change the status of the array?
You can, but it was coupled with like that doesn't it doesn't really matter because it's coupled with the in the DQ. So once you pop it off, it's gone forever. Like you can't
Once you
change the
pop,
status in like not the DQ, sorry, the heap, the old solution that got this wrong. The status is coupled with the box itself. So even if you change the array, it's not going to be like in the right order. You know, like just like in that example,
why
you would have
why
popped
why,
off
why
one and
did
lost
for
it.
for that example? If we had went if we had went to 0 first, where 0 the heap is doing from minimum to maximum, right? So let's say that order
No,
did matter.
other way around. It's maximum first. It was a max heap because minimum would be zeros. So those are lock boxes.
Oh, well then that would matter because then we'll do the 2 first, and then the 2 is closed.
Yeah, yeah, that was yes the problem.
and then you take it off. Okay. Yeah. So why don't we just only do the available ones? And when
I
we make
agree.
something available, put it in the queue.
Yeah, yeah, yeah. That's exactly what I'm thinking. Oh, what's up, software? I appreciate the lights comment. Glad you like the room.
All right. So I think I may be where you're at now. Um,
Nice. So I think this is all good. I think we just need to. What did I just do? So I think we just say wow Q, and then I guess we just pop um box from Q, and then we wait. Hold on. What do we
wait, what is this being used for? Explain this
oh,
for me
this
again.
is our cooldown set.
What, what does it take, and when does it release?
Basically, if we get a box that we don't have the key for, it's a locked box. So we put it in a set and we remove it from this set when we find the key for it. So it's like
Understood.
having the state decoupled from the box.
Makes a lot of sense.
So now we should add candies to res.
And what is this for?
Um, Actually, do we need that? Oh, because we need to have our keys stored somewhere. Because what if we get the key but we haven't found the box yet? So we need to
Isn't this
like keep the key.
what this is what you just said that was? Isn't the locked?
N- Other way around. Like that works if we have the box already. But what if we find the key prior to finding the box? Let's say locks is empty and we find key of two. We can't waste key of two. We have to save it somewhere.
Just put it in the queue. If the key is open, you put
Just
it in
because
the
you get
queue,
a
right?
key, just because you get the key doesn't mean you have the box. You need the box and the key to open the box. Having the key is not enough.
Mm, mm, okay, I did not get that part.
That's all good, man. I was sitting here for like an hour trying to do this, so I've thought about this for a while. But yeah, that's why we have those four things. So we pop the box from the queue. We add the candies to res because that's our candies we got. Next, we want to add keys to key set, and for this section, we want to iterate through the entire locked boxes. Um, Wait, hold up. When we get a key, do we want to immediately change its status? I don't know. I think there's something about before this. Check if
Yes.
we
So
uh,
once again, back to logic. So as soon as you get the key, you can change the key status to one, right?
yes. Oh, I was. That's what I was asking. I'm not sure. I think so.
So do we still need number six once again? Line six and seven?
Six and well. All right. What are you gonna do? Wait. Oh, immediately. You're saying as soon as we get the key, just change its status to open.
Yeah.
I guess you're right because the only way we'd ever actually get to it is if we have the box inside of our queue, right?
Yes.
That makes sense. Yeah. Maybe we don't need it. Yeah. Just comment that out for now. Good catch. So we don't need that as to key set for now. And then just change
So our
status.
actual DQ would have like um back to line five. Our initial
Mhm.
queue would have everything that's open and everything that's open and the status is open and we have available boxes to that status, right?
Uh, yeah. That's with the queue, and then all the stuff that we don't have. That's like we have the box, but it's locked. We put it in the locked set. I'm
So
starting doing C,
I'm
and I
gonna
like it a lot better than
because
C++.
we would need to
Really?
redo this, right?
Yeah, I heard it's better. Wait, redo it. What do you mean?
5.
But what do you mean by that? Redo it? Oh, like recomment. Okay, yeah. That are open. Yeah. And I guess we just say add locked boxes.
This could be like one for loop that if it's shit, this is
Yeah, I
yeah,
agree how we do
I
that,
could
but
do this part, but it takes a lot of brain. So do you all right? Should we come back to this or should we
yeah, I
like
think we should come back to that. Let's like finish the make sure everything else is working before we start implementing stuff.
okay?
So I'm saying like I use your idea here where we change the status of the key to not the key, the status of the box to open, the box of key to open, and then we check if the box. Wait, right? We want to check that if we have a box in our locked boxes that goes to that key, we then if so we add to queue. That makes sense.
Check if we have the box that goes to the key. If we have the box that goes to the key,
Oh, I guess the
what?
locked box. Like if we have the locked box that goes to the key, that means we could take it out of like the key, like the cooldown, and put it into the queue. Maybe I
Oh
should
yeah,
put
so
locked. Maybe I could say that is opened by the key.
so what comes out of this? Pop from the queue, and that would what would come out of the queue?
Boxes.
Just only boxes, right?
Yeah.
You see boxes that are open.
This is true. Uh, so we added it to the queue. Next, we have to. Don't we have to go to the locked boxes? So the contained boxes. Um, iterate through
Change status of box to open, of box of key to open, if any.
if any. What do you mean?
Because you may not have any keys. That box, if you open
Oh,
a
it would just be a for loop. So like it would just wouldn't run if it was empty. But yeah, I suppose so. And then have iterate through um, contained boxes, adding opened ones to the queue and locked to locked set. I think that's all we need to do. Appreciate it, man. We're grinding.
let's go through this while loop for an example. Uh,
Um, Probably should do an example that we failed because I think the regular ones are pretty easy. Considering my bad solution solved them.
so initial boxes you have 0, 1, and 2 will 0, 1, and 2 will be
Zero be in the queue, one two be locked.
0. Yeah. So we go into 0. We add the candy for 0, which is 1. So our res
Mhm.
is now 1. Change status of box of key to change status of box of key.
True. Or to one, maybe. So now status of 2 is now 1. Now we check if we have a box that open that goes to that key. So we'd put 2 out of our locked boxes into our queue.
If we have the lock box that is open by the key. Huh? So we need to. Oh yeah, we can easily do that. Capture the key, but we can just give access to it, indexing it. Okay, and then add it to the queue. Where if not, hmm, what is iterate through? Okay, so we added the what did we do here on line 19? We added the
This wouldn't really do anything because all the contained boxes are empty. But in another scenario,
so for this, for the example that we got wrong, this didn't really add anything to the queue, right? No, or did it? So
yeah,
Kenny's 111 status.
it would have had 2 to the queue.
Because two has.
We just picked up the key and we have the locked box, so we have a match. So we take it out of the locked box into the queue.
Okay.
Nice. All right, you said you wanted to do the list comprehension, big brain stuff.
I don't think it's list comprehension.
Oh, I didn't really give much thought into it. I just figured if you want to do it, it's probably list comprehension.
Um,
Oh, box equals q dot pop. It is indeed hard. you just do something?
Uh, I can think.
Be in contained boxes. What do you think?
Okay, looks good. Um, I like it.
Right. I said I'll be throwing in the Hail Mary. K is not defined. I did something wrong. Oh, for key and keys. Because before I had a key array, that's why I didn't use it. But it's. Oh, wait, no, I can't do that, right? I can't say for key and lock because I already used key, right? I've used. Wait, can I?
Yeah, you can.
Oh, yeah, because it's the same key. Yeah, I just need to turn these into keys. Oh, shit. We passed. First try? Wink, wink.
Hey, let's go.
Oh, man, we just did a hard problem. Let's go. Oh, that's cool.
Not bad at all. Why was this hard though? I mean, I apologize because you did say.
Yeah,
Yeah.
there were some hard times in that problem. Not gonna lie, I sat there for over an hour because you probably would have got it because you immediately thought to not like couple the things together.
Yeah, I guess the key lesson here is, what takeaway is that we didn't need the heap because it didn't require like an ordered approach. Would you say?
I mean, it does require an ordered approach, but we can't change the state of the key inside the heap. You know, like dynamically is really the issue.
Yeah.
There's another problem I looked at, and we don't have to do it. I just want you to read the problem because I tried it and I didn't even write a single line of code and I just left because I was like, yeah, this is above my head. But maybe you have some good insights. Because I thought I was getting somewhere. I wrote all these comments just to get nowhere.
I love the comments though. I love that you didn't code first. Yeah.
Yeah, I learned my lesson, man. With these hard problems, you can't just go right into the code. You're gonna be a sad guy.
What
The
happened to I don't do hard problems though? I don't understand.
I don't know, man. Like I felt kind of defeated after that last one. I was like, I need to get my get back. I, to be honest, that was the problem we just did was the only problem I solved all day. I failed that last problem and just went to bed. Woke up and did myself, don't you? Yo, this problem looks like is deceptively easy looking. That's why I wrote all these comments. I thought I was cooking until I got like down to line 18 and I realized it wouldn't even work. I feel you, man. When I first started out, I went straight to code too. But it's always good to write your comments. always wanted to get into Neovim, but like I don't know. I feel like the learning curve kind of scared me away, and I was like, I don't know how much time I need to devote to it. But I definitely want to get into Neovim. It looks so cool.
You may revisit nodes multiple times. Now that's freaking trippy, bro.
Yeah, because like you usually you would have like a scene set, but that won't work. So I don't know how do you stop cycles.
Right.
You want to hear my like solution? I was gonna do
Yes. I still don't
okay.
understand the problem. It's in the angle. Um,
Basically, you just want to find the shortest path to travel to all nodes. So like
oh,
in the first example, you could start off at 1, go up to
this,
0.
this is like the Hanao game. You know that Hanao game where you have like a stacked cube and like three lines?
I don't,
No,
but like what is this? How does it relate to the problem?
it does. It does. It does.
Oh, I believe you. I just don't know. I just don't know about this game. Let me look this
I
up.
spelled it right. Not sure.
Now, did I just get rid of that? My bad.
By the way, how'd you meet that guy? Nope, I spelled it completely wrong.
Hanao? They have Hanao. Oh, I see. Wait, how is this similar to the problem? We have 3 sticks and a bunch of rings.
Oh, Hanao Tower. Did you type in Hanao Tower? Is that what you typed in?
I
Wait,
just typed in Hanao game and it came up.
cool.
Maybe one
Why am
stream
I computer
we gotta
crashing?
do
What
it.
the heck?
Do some Lua files.
But yeah, and it's like you need to like order them in an ordered way. Anyways, um, um, you want to start off with explaining your solution, or
It doesn't work, but I was thinking just have a Dijkstra's algorithm for every node, right? And then you just go through and you're gonna have a dike map, and it would be the dike that would be the key would be the node and the value would be the array that you got from the Dijkstra's algorithm. And then we just go through every single node and say what's the minimum amount to get from node 0 to 1, right? That's 1. And then we start and we now we use the dike map and say from node 1, how do we get to 2? That takes 2, so we go 2 plus 1 is 3. And then we do the same thing for 3, 2 and 3, and you can add up and you would get the right answer. But there's something wrong with it. I forgot what was wrong with it, but
how do you know there's nothing wrong with it? You know,
no, I remember seeing it. I just forgot what's wrong with it. Something's really bad with it.
no, that, but the logic sounds really good though.
I
Like
know, right? I know, right?
you have a separate array for each starting point, right? Like let's say you start at because you don't have to start at a specific point, right? Do you? No, do you?
Oh, I know
Why
what
is the
happened.
graph? Why is
Why
the graph like this?
look at the answer. It says the shortest path and there's 5 nodes, but the answer is 4. That tripped me out so hard.
Oh, that makes sense now. Because it could be of any length.
Wait, what?
The graph, the possible path could be of any length.
But
So
why is the answer 4 if the path has 5?
I'm guessing they're not including the starting node.
Oh, yeah, I don't even know. That was the confusing part to me cuz
So
mine
from
goes
zero,
based on
1, 2, 3.
oh, I get it. They're counting edges, not nodes. And Dijkstra's kind of works based on like weights in a graph. This graph has no weights. I think that was another thing that made me just leave this problem. And then I scrolled down and looked at the topics, and it said fucking dynamic programming and bit manipulation plus bit mask, and I was like, yeah, I'm out of here.
We also have BFS, which is really good.
It's like one thing I know how to do in there.
we, we sort of know how to do DP, not at a
Yeah, a little
professional
bit.
level.
Not
Yeah.
not an elite code hard, man. I don't know if we're like that. We're like maybe medium at best. But yeah, Dijkstras I don't think would work because
Yeah,
there's no weights. And honestly,
several reasons why. Yeah.
I don't
But
really. I'm not
oh,
set on doing this. We could do something else. I just want to show you the problem.
wait. No, you put it in front of my face, and now it
Oh,
doesn't
all
seem
right,
like
for sure. If you could come up with a breakthrough idea, I got you. I'm down to try, but I don't know what to do from here.
initial approach is definitely like a backtracking approach in that we try every possible pass,
But
and
how do you
then
stop
the
cycles?
the yeah, and then we can go into memorization and then tabulation, which is
What?
memorization.
Oh yeah, or you're leading that then. I don't know. I don't know. Please help
But
me.
let's just start from the top and like understand how we can,
I'm
you
gonna
know.
delete this. It's none of that. It's good.
Oh dang! Well, that
Oh,
was a
my
lot of work.
bad. Oh, I mean we could put it back. I don't think it works. Dijkstra's one doesn't work.
Let's start the bottom. Oh, I mean it's up to you. I don't know.
Yeah, I'm just curious to see how do we stop cycles if we're using DFS. If you could figure that out, I think the question's easy.
So what if our visited is like a point of like
Wait, so you're making a
edges
vector, a
instead of like
dynamic array?
I can't hear you if you're saying anything.
Oh no. I'm good. I what's up?
Oh
I heard you said we have a visit of edges.
yeah, what if our visited is the edges instead of the nodes itself? So like say let's say we have like 0 to 1, right?
Yeah.
We can still go from 0 to 2, you know, and
Wait, you mean wait? We can still go if we go from 0 to 1. We can go 0 to 2. Okay. Can and we can still go 2 to 0.
0 to 3, right? We can still do all the things. And this is undirected, it can go both ways. I'm gonna just put an arrow here. So what if our visited is like a tuple of 0 going to 1 or 0
Yeah,
to 1?
but the only question is there ever a way? There's ever a reason why we'd have to travel the same edge twice?
Not
If
going
there's
in the
not,
same direction.
oh no. All right, if that's true, then yeah, we could do that.
So let's stick to that for a second. So let's say we have our visited. I'm just gonna call it visit for a second. We for whatever reason randomly start at 0 to 1, just randomly.
So we're gonna have a for loop that has to start from all of them and see which one's the minimum, right?
Exactly.
Okay. All right, I'll start at
And
0.
yeah, we just update our minimum for every iteration.
I think I'll just set it to infinity in the beginning. So 0, 1.
Yeah.
And now we got
So
to go 1, 0.
yeah, and we also need something to count. Like we know how much uh, nodes we have, which is n minus one, infinite. So we have equal 4. So
They give us n. Oh, I guess we just get n from the length of the graph. We'll make n ourselves.
yeah, we can say that. And so we can have something that says like we can either do decreasing or increasing. What do you want to do? Like we decrease until we get to 0, or we increase until we get to 4.
Oh, either
Which
way works.
uh, I like decreasing for today, so decreasing. So right now we had 4. So we've seen 0 and 1 in our visited. Then we're gonna say that we can go from uh,
Wait,
what do we have? Oh
why
yeah,
isn't this
so
down by 2 though? Because we just
yeah,
visited 2 nodes.
you're right. So and so we go to 0 and 2. Then we go into uh, we should have like an optimization of like nah, let's simple. Let's keep it simple for now. For like, so now we have 0 and 1. So we have a possible paths we can still take in our whatever this thing is.
Yeah.
We can talk about that later. And then we will choose. We already did 0 to 1, so that's not available to us. But 1 to 0 is still available to us, right?
1 to 0. Yeah, it is.
So we can decide to go 1 to 0.
I think I think that's our only option.
Oh yeah, because we're at 1, right?
Yeah.
Right, right. We must have a way to understand that we
Just
can
use the
only go.
graph. They gave us an JC list. Just start
Okay.
off at the thing.
And our D is still the same, so we're gonna keep this thing here.
Wait, how do you
And
ensure that like you're not reaching the different nodes? Are we gonna have to like look at each node and then what?
what do you mean?
Like, because you said the D should stay the same, right? But how do we know that this is a like this is we're crossing edges of nodes we visited before? Because we have to check that somehow.
Or our destination, if our destination, oh yeah, yeah, true. Maybe we have like a visited for nodes as well.
So like another scene set maybe, and it has like 0, 1.
Yeah.
Oh, I know what to do. Instead of having a counter, why don't we just have like what if we just had like a set and it had all the nodes in it? So like 0, and we just decrease every time we see them, and then eventually when D is totally empty, we're done. You know what I'm saying? So when we start off at 1, so we just like remove that, and then we go to when we start at 0, we move that. We start at 1, remove that, and then it wouldn't really matter because the only way to get rid of 2 and 3 is we have to actually traverse them.
Yeah, I think that makes sense. Let's do it.
So I think we can get rid of this end thing then for now, unless we
I
need
think
that for something.
what's the end doing again?
The end
Oh,
was
the
when
end.
you had the counter, but we have this now.
Oh yeah. Um, we would have to refill this every time though, because we're running this event time. We're
I
running this
mean,
thing.
maybe we could just have a global one and then just set it back, just reset it every call. I don't think that's that like computationally expensive.
Fine. Um,
So this has been removed. So we have 2 and 3.
so now we have these available to us. Um, wait, do we
So
have
we
0 to 1? No, we don't have 0 to 1 anymore because we did
no
0 to 1. So this is gone. Now, what we have available to us is 0 to 2.
wait. So are you gonna like actually make like are you storing this somewhere? Like all the edges?
Hmm?
Are you storing this somewhere? Like like how do you have this?
That's a
Like
good
where'd this
question.
come from?
We don't necessarily have we have our adjacency list of like what's possible, right? So
Yeah.
like every time we go through our adjacency list, we're only gonna take a path that we haven't done already, if that makes sense. So
Okay.
like our adjacency list will be everything, but we're not necessarily removing stuff from our adjacency list. We're just avoiding stuff that we've already done.
Oh wait. So I feel like wouldn't it help to just like have the JC list here? Because like now because we know we're at 0, so we look at 0 and we say that from 0 to 1 has already been taken. So we had just go to the next one, right?
Yeah, but this is much more visually helpful, at least for me, and to
No, we need
understand like
both. I was saying
what
instead
we
of
have.
this part.
Oh, yes. I mean, both is fine,
Yeah, yeah,
but
sure.
this is
We could have this too.
yeah. This is still needed.
Well, I don't think this is needed with the JC list unless it's just like personal preference. Oh, okay. Visually, sure.
Um,
I get okay. So we go to two
so
now.
now we at 1, right? Wait.
No, we just came from 1 to 0. We're at 0.
So this
So
is
we check a
telling us we're
JC at 0 and we iterate through its neighbors.
yeah. So we see that we already did 0 to 1, so we're not gonna do 0 to 1 again.
Mm-hmm.
So all we have left is 0 to 2 and 0 to 3 and back. So we're just gonna assume that we did uh bro, every time
What happened?
Since I seen that guy type super quick, I wish I could type that quick. Anyways,
Yeah, bro, yo, software editor is crazy. He casually types at 80 words per minute, like not on a typing test, just normally.
it's normal. It's amazing. 0 to 2. Cool, right?
Yeah, that makes sense. Oh, you did 0 to 3, so I guess all everything is. Wait, no.
We can go to 0 to 3. Yeah, I just wrote that
We
as
gotta
a
go. Yeah. Oh, okay.
we can
Because we can still
go
gotta go from 2 to 0,
2 to 0,
and then zero to
and
three, and then we're done because our D is empty.
yeah. So our base case is if this is empty,
Uh,
return, return. Uh, we needed the amount of steps. We should have been calculating the amount of steps we took. At no point were we calculating, but we have this. Nope, this does not tell us the amount of steps we took. No, it does. It does.
but there's
Because this,
5 things there. We need to return 4.
yeah, maybe we didn't do it optimally in this phase.
Oh yeah, no, yeah, we're supposed to start at 0. I'm at 1, not 0.
Yeah, yeah. So
I think this works, dude. I think you cracked it.
I think so. All right,
Yeah,
let's
honestly,
comment.
it's been an hour, and I go to the bathroom. I'm down to take like a 7 minute break. You down too? And then we come back and knock this out.
Let's do it.
All right, yeah, I'll be back. I go to the bathroom. All right, yo, software dinner, bro. I don't know, man. This is a pretty hard problem. After I hop off, we could do something easier, man. I wouldn't recommend something like this for like if you sent you new to Leetcode, man. I don't want to put you through that. I'm back.
Nice.
Isn't it crazy to see like how much we improve? Oh, remember when we first started? Like we were like I don't know, just kind of getting into backtracking and stuff.
Yeah, we've come a long way, bro. From
Like
one one.
for real, this the grind is real.
All right, let's do this.
Okay, this seems almost too easy for to be like a hard problem, but
No, it still is hard because, like, even thinking about it, I was like, while you were away, I was like, "Hmm, there's a lot of stuff we need to keep track of, and our solution right now seems like it may time out because we have to do uh, O of n times n squared solution. No, 2 to the n solution, because unless we have a lot of uh, edge cases. Yeah.
one thing I noticed is if you scroll down, the max
Yeah.
length of the grid is only 12. Like I've never seen constraints so small.
Yeah.
Like that's crazy. 12?
So 2 to the n is like, where n is
That's
12. 2 to 12 is still pretty big.
but like usually it's like 10 to the 40th or something. No, it's
Yeah.
not really. It's like 10 to the 4 or something. But maybe is that big? Is that like worth is this worth implementing right now or is it like we have to figure out some optimizations?
Oh, we can optimize it as we go along. Like we can add memoization onto it. It is a memoization problem.
This is dynamic programming. I didn't look.
No, you told me in the beginning.
I
Isn't it?
did. Oh,
Yeah.
Yeah, I just came back from that. All right. So this is like the heaviest brute force solution, and then we're gonna optimize it.
First, pray that it works, and it submits. If not, then we can optimize it.
Yeah, I feel like this is not gonna work out. I mean, not initially. I think we might get it after because I don't know. I've never solved two hard problems in the same day.
Really? Is that true? I feel like we may have.
Fuck no, two hards with like not like I didn't get any help the last one. Oh, I guess you helped me, but like we really just did it like out the mud, like no chat GPT or nothing. All right,
I remember,
but wait, what happened?
like, we did like word ladder. We
Oh, yeah, I
we
guess that does count as a hard problem.
it's hard, bro. Damn. I mean, I guess we're that good now. Some hard problems are not hard anymore. I guess. All right.
I feel like
I'll
the
take that.
range of hard is crazy. There's some mediums that are definitely harder than hards.
Sure.
All right, so we have
And
the JSON list. We don't have to make that. I guess we just have our. I guess we have a.
what?
Wait,
We
what?
don't have to make the adjacency list.
Yeah, because the graph is in JSON list.
I can flow with that. I can flow with that. Um,
Uh, so I have min, and it's just gonna be um to store the minimum number of steps. Next, we need
main steps. What do you mean?
because we want to find the minimum amount. So like we need to update some type of global variable.
Oh, isn't that our res?
Oh yeah, you can call it res. Yeah. Uh,
And that's a
tool.
good optimization too. So that in our
Oh, if you ever go
backtrack,
above, just skip.
yeah, just,
Yeah, I
yeah,
guess. Yeah, I agree.
that's not optimal.
Um, so we're gonna have the scene inside of the DFS call.
Yeah, we have to because every time we call this, it'll be a different scene.
Okay, yeah, so DFS with
Can I write this? Takes.
oh yeah, sure. I forgot you like English, like pure English comments. Current node scene and D for I don't know why. Why did we call it D?
What's D again?
Remember it had all
Oh,
the nodes in it and we subtract? I don't know why we called it D though.
um, I don't know. What do we want to call it? What is it?
So we
What
have
is the previous?
nodes, we have scene.
Uh,
It's to tell us when we've
node,
visited all the nodes.
seen and
Nodes?
visited. I don't know.
Uh, I feel like, oh yeah, but I feel like we should name it. Scene and visit sounds so like similar.
Well, one is a path, and seen path, and then seen visited. Do we want to?
Yeah, maybe call one path. Call one path.
So this one's path, and
Wait, it's not really a path. It's kind of just like a list of edges. I guess it is. Is it? I don't know. I don't know. Scene edges. Yeah, that. Yeah, yeah. And then we have scene for the nodes. Yes, beautiful. And the current node. I like that. Um, base case if
wait, not seen, but this is not seen nodes because this will contain nodes that we haven't seen.
yeah, yeah. Do you want to change the name or just keep it? Unseen. Yeah, there we go. There we go. Unseen. So if unseen set is empty, return the you need a minimal because we have a global minimum, but we need a local
Oh, yeah.
minimum. Current min and current node. Yep. So if seen is empty, unseen is empty, that means we've seen all the nodes. Return. Next, we need to loop through neighbors of current node. If edge in node in scene. Well, I just maybe I just say not in scene. Not in scene. I guess we need to make edges because they don't actually give us that. But that's
Yeah.
not that big a deal.
Yeah.
And then just return res. That seems too good to be true.
Loop for neighbors of current node. Yep. If edge node in our scene, add to scene. We need to remove our
Oh yeah, yeah, yeah.
somewhere. Uh,
Move, remove
and we also need to update our.
node and a from scene
We add it to
from
scene,
unseen.
and then we need to uh, call.
Oh, that's what I meant by traverse. But yeah,
Oh, are you dead?
yeah. When I just said traverse, I just meant like call DFS. But yeah, you could write it more explicitly if you want.
and then we need to increase our uh, current min
Oh yeah, +1. Yeah.
one, and then we need to add it back. Add back the
Oh, the nodes. Yeah, you're right. Forgot backtracking. And subtract min by 1 because if we backtrack, doesn't that mean that
no,
we
but we
gotta?
would do it like in
Oh, you're
place, so
doing it
we would.
inside.
Yeah. But I'm a
So
little
why don't you
confused
just do
there
that inside too?
because we're removing from there. It already came inside. Does that make sense?
Oh yeah, we're moving it. Yeah.
Unless we could remove in place. I don't know how to
Nah,
do
this seems easy enough.
that. Node NA. So we're moving from unseen. Which unseen are we? Oh, unseen nodes. I'm confused. I'm confused there. Help.
Oh,
If edge
oh,
not if edge node name not unseen.
yeah. So we never traverse that edge. Then we add that edge into scene, and and then we remove the two nodes, so node and neighbor, from unseen because those two nodes we just saw.
Oh. I think this is confusing. I just put this into line.
Oh, all right, no problem.
And then add back to scene.
Oh yeah. So this is unseen, and then this is what's the other one called? Oh,
Scene edges.
scene. Add to scene edges. Wait, doesn't that mean that we have to? Oh, so now we have to add back to scene edges right here, then, right? Wait, I don't know.
Wait. Wrong. Yeah, something's wrong. Like so node and neighbor. So we're gonna add the node and neighbor in our into our scene edges, right?
Yeah, yeah, yeah.
Which we're doing right here. We need to remove that from our
And remove the two
unseen
nodes from our unseen nodes.
if possible, and then add back to unseen nodes if possible, because we
Oh,
may be trying to remove something that's let's just make sure possible.
so we remove from unseen nodes, and then we add to edges. Don't we have to? Don't we have to add back? So we add to edges, but don't we have to remove it once we come out?
Add to scene edges.
Because we
Uh,
backtrack this work, but we this edges is still messed up. Well, not messed up, but yeah, it's
sure.
messed up. I think it's not. It's not that big a deal. Just like add. Wait, no, remove edge from.
And there needs to be also a case that if we found a minimum path, no,
Oh, they're
no,
talking about the optimization.
yeah,
Oh, just up here.
yeah,
If cur min less than res, return.
return, yeah, return. Um, so there may be a time where we were traversing a path and we couldn't find an optimal answer or answer that's less than our current res. And so
Wait, wouldn't that mean it
should
would
we,
just return?
yeah, we should return something though, because this is gonna on line 33, we're going to compare that answer to our current res. So we should return
Big number. Flow
a big
infinity.
that's what I was
Yeah, or
This
1e9 or something. It doesn't matter. Some number that's never gonna be possible. All right, perfect. All right, so I have n here. Res just integer. We need a non-local, right? Because yeah, we need
but
the
there's also
non-local.
something. No, we're not reassigning ours.
Wait, wait, wait. Isn't that the min though? Every time we go in. Oh, you're returning. Oh, you. I get what you're saying. I thought you were just gonna call it and the DFS function will update it, but you want to set it inside after the for loop, its return statement.
Yeah, that way it's because memorization usually doesn't have like non-local, so I'm like trying to stay ahead of
Oh,
the game.
so we have to have a return. Do we have a good? Don't we need something on the bottom to return something?
Yeah, yeah, eventually. But I was something. I saw something else um, that didn't seem right, and I can't remember. Um, but um, so we so we got our res. He gets it, and then I shit. I had something. Um. Okay. What do you think? What do you think? Maybe it'll come back to me for this.
I guess my only question is it a problem that it does? There's no return statement at the bottom. I guess it would just end. No, I guess it has to hit either the base case. So I guess we're fine.
Should we just return our current min?
Yeah.
No,
Okay.
no. We should only return the current min until we visited all nodes, right? So if this condition doesn't return, we should just return infinity and that we never was able to uh
I feel like that would
get
never
to.
happen though, right? Because unless there's like nodes that aren't connected or something, right? Oh,
Oh
look at
yeah,
the constraints. The
that's it.
input
Sort of
graph is always connected.
it's like if we return here, this could return and say that we can block us continuously, and then we'll go outside our for loop and have to run whatever this is.
Wait, explain that again. You said this will block us continuously.
Yeah, because like let's say we try multiple paths uh, that is not able to like exceed our minimum, our current res minimum, it would continue to return and backtrack and then try other nodes that if we have other nodes available, if it doesn't, it's going to go outside the for loop. The for loop is going to end because there's no other nodes it could try and then run here.
Oh,
Did that make sense or still no? If it didn't make
it
sense,
makes sense, but wouldn't it just mean that this returns nothing?
yeah, but we don't want that, right? We want it to always return something.
So just return infinity.
Yeah, exactly.
All right. Alrighty. This looks this looks decent.
Ready to start?
Yeah. So we have DFS. We have clean edges, unseen nodes. I'm just gonna call it min. Wait, no, is that bad naming? I'll stick to the cur min. You said we don't do non-local, but how are we gonna do line 19 without like how is this function gonna be able to see res?
It just does.
Oh, we can view it, just can't change it.
Yeah, exactly.
Oh, okay. Kerman greater.
So our sin edge is of type This is going to be tuple, right? A set of tuples, right?
Yeah, yeah.
Now, current minimum would start at infinity, right?
Yeah. Oh yeah, I don't know why I put 0. Return
Oh no, our NC node should start with things inside of it. I'll fix that. Our current node is
for Renee current node. What happens if you try to remove something from a set that's like not there? Do you get an error, or is it like return one -1 or something? Because on line 32 you said if possible. So like, is there a problem if it's not possible?
I think we may get an error for trying to access something that doesn't exist.
I guess I gotta check if it's in there first.
Yeah.
Okay, that's only O of 1. It's not that big a deal. That's so stupid. What? Is there any way to do that? Not like with a bunch of if statements. I have to do one for the node and one for the edge. I'm gonna look it up. What happens if you try to remove a value from a set that doesn't exist? Yep, it raises an error. Oh, dude, you ever heard of discard?
Yes, I have actually.
Yeah, we gotta use that. It removes, but it doesn't throw an error. Beautiful.
Cool.
Scene dot. Scene nodes dot discard. Scene nodes dot discard.
But the thing about this is though, no, I don't think that'll care. Okay. I am now in the DFS function here to help if current man
Okay, I guess you could double
great.
check if there's any problems. Dot. Scene nodes dot.
Ah, dang. Um, so set beginning of 0.
Edge from scene. So edgeless. Scene edges.
I hope this returns a node.
Wait, what's happening here? Total equals.
Do you think this would return the set?
Wait, what is that? What is nodes? Nodes
Nodes is
equals.
the current the nodes that we have. It's it's
Oh,
unseen edges, unseen nodes.
node and nodes dot discard. Oh, and the discards because we've seen the first one. I don't think you have to do that because look at line 33, 34.
Y- Oh, you're doing both the parent and the neighbor?
Oh, yeah, unless yeah, that was my idea. I was gonna add both.
Um, all
We
right,
can
yeah,
just do
we're
the
gonna.
neighbor if you want.
I'm not which one works or which one doesn't work. So would this throw an error anytime? All right, let's
Well,
say we
discard
didn't
doesn't
add.
throw any errors.
Yeah, yeah, but would it give us the right answer? Is what I mean. I'm sorry.
Oh,
Let's say this is just set. Let's just say that for now, and let's see if this works. So in the first iteration, we would add the parent 0 and then 1. Oh yeah, you're right. So yeah, you're right. That's fine. Because like I said, this card doesn't throw an error, so we can just willy-nilly try it every time.
yeah, that was my thought. I was like, no error, fine by me. All right, I guess let's give it a good old trace.
Okay. So uh, gonna trace the first one. Okay.
Yeah. Uh,
So we'll,
I guess
we'll
only.
start at
Are we only doing 0? Or are we doing the whole thing? Maybe just 0 and 1, right?
we just want to try 1 because that's
Sure,
the
let's just
answer.
do 1 because we yeah, that's the answer. Yeah.
All right, so we're gonna start at 1. So our set is empty. Our seen edges is empty. Our unseen edges is empty. Wait,
We had 0, 1 because the parent and the neighbor.
wait, I did something wrong. I said this should be nodes. Okay.
Oh,
So all right, so our nodes has everything 0 to 3. Our current min is infinity. Yep. And our node is 1. Okay. Uh, current min is infinity. Infinity is greater than. Nope. Infinity is not greater than res.
wait.
Infinity is
I
greater
don't
than
think
or
that's.
equal. Infinity is
But
greater than infinity. Is infinity greater than infinity? Um.
current min should start off as 0 because we have to count up the nodes we see.
Okay. So yeah, that's right. That's right. That's correct. This is why we trace.
Yeah.
So 0 is not greater than our current res, so we're not going to return. If not unseen, return current min. So start at 0. Well, we're at 1. So one node available is
0.
0. So path of node to nade is 1. Wait,
Yeah.
what? We just
1
got
and
that?
0.
Yeah. And did we remove something here accidentally? I don't know. On line 33.
I think so. Wait, something's not right here. Yeah, it was. Hold up. I don't know why that disappeared. Okay, we gotta go put the. What else did I don't know how they got deleted. I'm gonna set the minimum back to 0 and set the set back to nodes. Okay, there we go.
Cool. So path not and seen edges makes sense. Unseen edges, unseen nodes dot discard node. So we discarded the 1 and we're gonna discard the 0.
Yeah, so we should just have 2 and 3 left.
Seen
Add
edges
the
added.
path.
So we add 0 to 1. So we'll never.
Mm-hmm. Wait, no, we add
But
1 to 0.
0. Yeah, 1 to 0. So we'll never do that again. Then traversed again. We
Oh,
should
sure, you could
then
join. Next question.
go back into our folder because none of these would run. We'd see that we'll go from 0 to 1 because we can.
Yeah.
And then we would exhaust. We couldn't do anything at 0 to 1, so we would backtrack that. We would backtrack there and then try 0 to 2, right?
Yeah. Mm-hmm. And
0
our
to
min
2
should
would
be at what's our min? Our current min at right
still
now?
at 1.
Oh, okay, yeah.
So 0 to 2, our min will then increase to 2. At 2, we can go from 2 to 0.
So we go to 3. I guess min
Yep.
min would go to 3.
We're gonna try 0. Yeah. So we're at 0 again.
And min is at
And then
3.
yeah. Yeah.
Okay.
And then we're gonna try 0 to 1. 0 to 1.
1 and 2 have already
Wait.
been traversed. They won't work.
Yeah. So we'll try 0 to 1. And we see that it. Wait, is that in our scene already?
It should be.
Or did
Wait,
we
why would it not
backtrack
be?
that out?
Oh, wait, hold wait, hold up. So 0, 1 goes to 0. Wait, why would it backtrack? Because 1 goes to 0,
0
then
goes to
0
2.
goes to 2, and then 2 goes to 0, and then 0 goes to 3.
Yeah, 0 would try to 1 though first before he gets to 3 because it's a new iteration.
But on line 31, it says a path not unseen. It wouldn't even run, and it would just go to the next iteration in the same DFS call.
I just wanted to make sure that we didn't backtrack and put it back into scene. I mean, take it out of scene, the path, because. All right, we'll get there if we get there.
I don't think so, but
But yeah,
anything could happen. All right, let's do
yeah,
it. Unexpected indent. Okay, that was anticlimactic. Something's wrong with line 55.
55,
Software dinner. Are you excited?
55. This.
You're gonna hop on.
Oh, this is not a.
Unseen, not defined. What did I do? Oh, unseen nodes. Okay, we got null. Isn't that lovely? How do we get null? Shouldn't res be like infinity? At worst case?
Oh yeah. The thing is, we're never returning current minimum, right?
Once we see all the nodes, we are. Oh, it's like really deep in the call.
Yeah, we have to
It's
return it
lost.
here. But the question is, would the first current minimum would the first traversal that we exhaust be the minimum path, starting at that one? Does that make sense?
In the
Because
first
we could
example,
easily
it is,
exhaust
but
that. Yeah.
yeah, because I guess if the first node you're starting at has a bunch of different options.
Or an easier fix is just assign a res right here.
Yeah, that was remember that's what I was talking. I was saying, and
Yeah.
what you were like the memoization. I was like, okay, this is definitely not like the purest solution. I feel like there's a way to do it on line 38 where you just say like if DFS returns something, then we know it the path is able to get all the nodes unseen, and then we save that somewhere. But that's too like big brain for me.
Yeah, my only issue is that is like we can return this our current minimum once we found a current minimum, but like I feel like we would stop exhausting all paths. We may need like I guess a way to ensure that we do the shortest path first. Like wait, yeah, I'm not sure if the first pass will always be the shortest path, so I'm not even sure. We
I
can
thought our
try that
point
out.
was that we're doing everything though.
Yeah, yeah.
So we're just
Anyways,
gonna
let's
say
just
that res equals. All right, I'm a non-local it. Gal res equals. I guess technically we don't have to return anything anymore.
yeah, just return. It's fine.
And then
And
down here we yeah, I guess we don't even need a total anymore either. Just call DFS
yeah.
return res. All right, let's try it. Kerman is not defined. Kerman. Oh, I use one R. Okay, let's try that again. We got the first one right. Let's go. We got 5 instead of 4.
So we missed the path that it could have taken.
Yeah, I'm guessing it added because we start off at 0. I'm guessing it added that path from 1 to 2.
What do you mean?
Like you see how the optimal path doesn't include 1 to 2. I'm guessing since our answer is 1 over, I'm guessing we added it. Because that'd be the only way we have 4 edges, 5 edges instead of 4, because we used up every edge available.
Still don't understand why we got the answer wrong though. We should have tried every path.
It's the I guess it has something to do with how we're removing edges. I think. We might need to
Yeah.
print something. Maybe print path. Maybe to see where we're going.
Yeah.
All right, we go 0 to 1, and then we go straight back 1 to 0. Of course we do.
Which is fair.
But
And
now
hopefully
our thing went up, so it goes 0 1. Wait,
But we should backtrack though, right?
Oh,
Eventually, we should have back. Oh, this
okay,
is
yeah.
so
Wait, so
too
did it
much.
end? Holy shit, this is so long.
Yeah. Let's do a prompt that tells us what one call is. And
Oh man.
my goodness, one call. Oh, one call is super long. How do we efficiently like?
That's insane. Where did we go? We went from 0 to 1, then 1 to 0, and then 1 to 2. So after 0 it oh yeah, it ends cuz we can't go anywhere. I think you should print the min with it as well. I'm going to do it. Path and cur min. Wait, shouldn't you put backtracking before you go backtracking? Cuz or it doesn't matter, or maybe not. I don't know. Why is there so many backtrackings like right after another without printing anything?
It exhausted all the possibilities.
Okay, so we went from 0 to 1, and we went from 1 to 0, and we're like, hey, that's not gonna work. So now we go from 1 to 2. That's already a problem. We went from 1 to 2, but our current min's at 1. But we traveled from 0 to 1 to 2. It should be at 2.
Yeah. Do we ever try 1 to 4? Let's see. Uh, yeah, we did try 1 to 4, but our min is at 6. What? We need a 1 to 4 where. Oh yeah, we did try 1 to 4. We did try 1 to 4 where our min is at 1.
You know that at cache thing that like if we call a function with the same parameters, it'll like just return what it did before. Will that help us?
I'm not sure. I don't really understand that much, to be honest.
All it does is like it just has built-in memoization. If you call a function with the same parameters, it'll just return whatever the previous computed example was. But
Mm.
I don't know if we're calling DFS with the same parameters over and over again. But there seems to be an issue as early as line 4 because we go from 1 to 2, but the current minimum is only 1. But that's not like possible because we had to start from 0.
What do you mean?
Because we
The
started
one.
from 0, like we started from 0, and in order to get to 2, wouldn't you have to?
No, it
Oh,
is.
never mind. Oh, no, I'm looking at the path we didn't actually go there yet. Okay, and then we went back 2 to 1, and then it goes 1 to 0 again. Oh my god.
Now, if you scroll down, what we need to look for is, does it ever go from um 1 to 4 with a minimum cost of 1? That does exist in our
1 to
print.
4.
Yeah, with a minimum cost of 1. It does exist.
How is that pop? Oh, before you travel. Okay. Shouldn't it not be that far down? Because it's like right
No,
there.
that's understandable though, because it tried. So we did a DFS. It went down a long path instead of a BFS, where we try everything. So like, it went down a loop where it's not the optimal answer, and so like, so it had to backtrack a lot to get to the optimal answer. So did you see the 1 to 4, the print of 1 to 4 and then 1?
No. I see 1 to 4 and 3. Is there like isn't there like control F or something? To, think it only can find stuff that's like. Do we ever go 1 to 4?
I see it in mind. I do see a 1 to 4.
With the cost of 1?
Yes.
How far do you have to go to find that?
Uh, it has 1, 2, 3, 4, 5, 6, 7 backtracking. The words
Oh,
backtracking where it is. Right after it. So if you see like
see 1 to 4 with 6, 1 to 4 with 4.
not
One
all the
where the
way
fuck?
down. Uh,
Okay, maybe I
maybe
went
I'll
too far down.
share my screen again. Let me
1 to 4 with 5. Where the hell is this thing at? 1 to 4 with 1. How far do you? Okay,
oh, this is me, and then I scroll down. No,
1 to 4. Okay, so with this, now what?
so we need to see if it goes to 4 to 2 with its cost of 2. I got 4 to 2 with a cost of 7. Uh, mm. Let me see if it. Oh, yes, it does have a 4 to 2 with a cost of 2.
Oh, we
And
only need one more. Now we need a 2 to 3 with a cost of 3.
hey, there it is. So we should have
Two to
exhausted
three.
all possibilities. So what's the issue here? Because then our is the issue that our unseen nodes
Wait, so what
is
happens when
not
we
in.
go to 3? Wait, oh, wait, because don't we have to call it on 3? And that's where we would return the answer.
Yeah.
So
So
what?
our
What
minimum
should?
would have increased to 4, which is the answer, and then that should just uh, our 26 should have ran right at that point. Maybe we should have seen if our 26 ran.
Oh yeah. Oh man. Oh, it found its no. What the fuck? It found it with 10. Found 8. Found 7. Well, I think it's not going to be here because we would have had the answer if it's there.
Yeah.
What the fuck? Like that's so weird. Why did? Maybe we should just hone in on that last part where it was at 2 with a cost of 3 and see like what happened after that or like more information about that call.
Mhm.
Yo, what if it went backwards? What if it went to like? What if the next call it went to like 2 to 1 or something, or 2 back to 4? Like you know.
Yeah. Where is that 2 to 3? Oh, it is there. Oh, yeah. What? Why? What? Maybe we should have. Yeah. You were saying maybe we should print our unseen at this point. Unseen nodes? Why is unseen nodes like? Because how would we get here? I mean, it's clearly our unseen nodes are it still has value, which is why we we are. syntax error. Where?
Oh, my bad. It's fixed. So it just doesn't go to where we need it to go.
I think it does go, but it doesn't like our, because we do have a 2 to 3 with a cost of 4, which is what we want.
Wait, you see it? Go ahead, 2 and 3 with a cost of 4.
Yeah,
And wait, what is our unseen nodes look like?
4, 0, and 1.
That's really bad.
Yeah, but it went to 2 to 3. Like it's 2 to 3 is right there. It's in the path. Like why did it not add it? Like,
Wait, what are you printing?
oh no,
What
oh
is?
no, no. The
Shouldn't it
issue is
have
that
removed it?
oh, yeah, it should have removed it.
I guess 2 and 3 aren't there. Everything else got added back. So I think it's the
Yeah, maybe we're adding stuff too early. That's crazy though.
yeah, you're printing unseen nodes. And we've discarded those two.
Because there's no way that we can get to 2 to 3 without going through 0, 1, or 4. Like, so why, like, and we started at 0 because there is no end here that says that we started a new backtracking, right?
Hmm. You're like a hawk. You have hawk eyes. I don't know how you're looking through all this and find this stuff so fast.
So
Yeah,
let's
we have 2 to 3. The cost of. I'm just looking at your screen because I can't find that shit. Two and 3 with a cost of 4. Why would that never return?
because our scene has 401. Why does our scene have 401? Is what I don't understand. Like, I don't want to naively just remove this because then everything will then be added.
Yeah, I think removing it. Yeah, then we get a bunch of early conditions that think it's done. Is discard maybe discard's not doing what I expected to do? I don't know.
You think so?
I really don't know. Let me make sure discard does what I think it does. Discard for no, it works. This is sad.
Because it's removing stuff here and there. It doesn't stay the same length. So I mean, right? We start at 0, where 0 is 0, 1. We remove the 2, 3, and 4.
Oh, I think I know the issue
Yeah.
because we're adding the node and the neighbor back. Like, let's say we went from like 1 to 2 and we backtrack back to 1. 1 should
Hmm.
still be there. It seems like, you know what I'm saying?
Oh, the parent should still be there.
Yeah, because we backtrack, we're at the parent, but we're moving the parent. I think we should do that way you did had before and not do the parent. Just do the neighbor. I'm not sure if that's going to fix it, but that seems like a potential error.
Okay, let's go for it. I'm not sure either.
But doesn't that seem like a problem though? Like if you backtrack and then you remove the parent that you're currently on. I mean, you add it back, but it shouldn't be there.
Yeah, but we're gonna add it right back right here. Next question.
Oh. Yeah, yeah. I guess you do remove it back. Eh, I don't know. You know, we could do. We could just do a thing where like everything is inside of the DFS call, so we don't have to worry about like how we're removing it.
Oh, you know how to do that with a scene, with a set.
Yeah, you gotta do this set union thing. You gotta use that pipe.
Oh, yeah, let's do it. I thought we didn't know how to do that. This was.
No, we did this
Yeah,
together one time.
but the thing is, the issue was that we were trying to remove something that shouldn't be removed. So I don't know.
Oh, maybe we just do the reverse. Like maybe we add the nodes, and then once the nodes equals the length of n, return.
Oh, oh, yeah, yeah, yeah. That'll make it easier.
I don't know. We do all this work, it doesn't even work. Uh, damn, that was been another 45 minutes. You know, time flies when you're having fun. Uh, what do you want to do? You want to take a 5 minute break or just do go another like maybe 20 minutes?
I feel fine. It's up to
All
you.
right, yeah, I'm put a 20 minute timer on, or 25. Let's see if we get done in 25 minutes.
Okay.
All right, so first order of operation is we're gonna do a set with the node in it. Yeah, I think what you had was good. And then the base case is gonna change if are we changing the name or not? Wait, isn't there some like tool that lets you change like everything at once? Like you change all the unseens to just the word scene.
Yeah, I could do that.
Can you do that? I don't know how to do that. Was it gonna change the comments too? I mean, I guess it doesn't matter. And just change it to scene. Oh, yep, perfect. And
Then we have to flippity flop these.
if we what?
You have to flip these.
Oh, I thought we were doing everything inside the DFS call.
Yeah.
Oh,
No.
actually, let me fix this base case before I like get distracted. All right, if length of scene is equal to n, we should do that. Okay, add the neighbor, add the edge to path. Wait, isn't that like not what we're supposed to do? Because I thought we were like actually changing it inside of here, and then we don't need anything outside of the DFS call.
Okay, you have to do that.
But I mean, you could leave it for now. Maybe let's just test it out because I don't know. This may work. Key error. What happened? Oh, because we're trying to what? Scene dot add neighbor. You backtrack and then scene nodes dot remove. How does that not work? You're trying to remove something that doesn't exist, but we just added it. All right.
Yeah, that makes no sense. We added it and we're removing it. Why would we remove it twice? Is the question. Is
Yo,
yes.
this is insane. What the fuck? No, I mean, that's why this question is hard.
Oh, we could remove it twice, right?
Wait, why? How?
Because our edges is like saying we can see this. I don't know. It's complicated. But our edges is like saying like there's like you know we're doing edges and not paths, so like we could do this multiple times. Okay. But
Oh,
let's
like
go back to this card, I guess, and see if that helps.
okay. Now we don't. The first one doesn't work anymore. Output 2. How the fuck can you
How do you
possibly
even get
visit all the nodes with only 2 spaces?
is our condition right?
I said
Length
if
of
the
scene.
length of C nodes is equal to n is like the length of the graph minus 1. That makes no sense. Holy smokes. Oh shit, it's Vortex. What's good? He said I'm not good at this. Are you crazy? You out your damn mind. This is literally a 2200 rated problem. I think what you were saying made sense. You're like, because the path is like directed, so we would go through and like add stuff twice. I think that's
Yeah.
really the issue. I don't know how to fix that though. Like, because we go from 0 to 1, we'd add both of them. And then if we find the path 1 to 0, it would add them again. But it's a set, so shouldn't it be like not matter?
Yeah, it doesn't add them again. It just says like, oh, we already have this, so we're just gonna leave it alone. But if it did add it the second time, then we could remove it.
Well, man, I don't get that. I don't understand why this doesn't work. I don't understand why the answer is 2 now.
I'm trying to figure it out. It seems like it doesn't reset. So like in the first one, it goes from 0 to 1, and then we go from back to 1 to 0, which is correct, and we still have the right. So then we go to 0 to 2.
You know what
It
I'm
said
gonna do? What happened?
it's fine. Oh, n should be 0 to 3. Shouldn't that be n plus 1? Because n, you said n minus 1, but it's really n plus 1.
Wait, what?
Uh, the length of the graph, which shouldn't that be n plus 1? Wait. Yeah,
Wait,
because
n
it's
minus
0
one.
minus.
That would be 4, and wouldn't that be 3? Oh,
Yeah,
length.
yeah.
Wait. Oh yeah, it should just be n. You're right. Good catch. Imagine
No.
that's the whole reason. No.
So wait. You didn't change it though. Did you change it? You didn't change it.
Wait,
What did
but
you?
oh yeah,
What did you
plus
change?
one, plus one. I thought you changed it. I thought you changed it. My bad.
The
Okay,
length of
we
the.
were back to where we started. Woo! Let's go, brother. He said, "Do I need to donate?" Honestly, no one's ever donated before. I don't even know if something's gonna pop up.
Alrighty.
Or what do we get? We got 7 now. Before we got 7 is insane. That's more edges than edges are allowed. For
I mean,
some for some reason, it thinks that it has to travel 7 times. It even found one with 8. Like, did it just did circles
yeah.
around itself,
And then it found ones with 8, and then. Hmm,
and then there's just a drought.
yeah.
Found one
And
with 7. Yeah, I guess seven's the best because that's what it returned. But
wait. So from zero, starting with 0, it didn't find lesser than 8, which is a problem here.
wait, I need to be affiliated. Wait, no. Go into the description
0 should
of
have been
the
our option,
the
right?
stream,
From
and
0
you
to
go to
1.
that link. It works.
Yeah. But how did it go to 2 to 3? It went for 2 to 3 for count of six. But it said it missed the zero. Zero is where we began. How do you miss the zero?
Dude, honestly,
Don't,
I don't know if this is gonna fix
yeah.
it, but let's just do the thing where we do like the set union, where we don't do anything outside of the DFS. Like that's my Hail Mary solution. So scene edges is just gonna be scene edges, and you just do this thing here. That's not what I meant to do. You have this pipe, and it's just gonna be scene edges, and then you're gonna have whatever you want to add. So in this case, a set with no with path, yeah. And scene nodes do the same thing. Just the pipe, and then set with the neighbor. And now we don't need any of that. Let's go.
Yeah.
Hopefully this fixes it.
I don't know if it helps, but print it.
Nah, but it's just let's go. I told you. I told you. I told you. I told you.
No,
What you gonna say? What you
bruh.
gonna say? Nah, well, let's
I
see if it
got
works.
mine.
Let's see if it works.
Okay.
Nah, output limit exceeded. Holy shit! I think we got it right, dude. I think we got it right. We just gotta delete all these.
Oh my goodness, I'll be so hyped. My goodness.
This is a hard problem. Holy shit! Like an actual hard problem. Come on. Hallelujah. Come on. Why is it taking so
That
long?
matters.
No, I might. No, we're cooked. We're cooked. Output limit. No, time limit exceeded. Fuck. Dude, you know why? Because this way is so slow because it creates a new set every time. We need to figure out how to add stuff and remove stuff efficiently. The way we had before is faster, but this way it just causes less errors. Because the union like makes a brand new set, so it's O of n. That's the problem.
Every single time, like I don't understand what. Like, I need to understand the logic of how is that not removing and adding in place. Like, why is that not a thing?
Yeah, I thought it was two, but it's clearly not because it wouldn't have gave us two different answers.
Yeah, that's
Oof.
crazy.
Damn. They know, man. They was like, you even try this? We're timing your ass out. All right, so we just need to figure out how to do this the correct way. Damn it, dude. We're at the precipice of greatness. You know how happy I can go to bed after this if this was worked? Fuck.
Thing. You know, we're having our print statements anymore. I mean, yeah. Well, we know the logic works. We just need to figure out how to optimize.
Yeah.
So what's like what are we doing more than once?
Probably
You can
calling the same function over and over again with the same parameters.
can we memorize it now, saying that if we're at this node and then we've found a path to get to this node that's already shorter for that example, for that starting node, we just return.
Oh, yeah, we could do that. See, of course you got banned for scamming. What the fuck? Yo, you remember that? I swear, man, that at cache thing does something. I know it's just dynamic programming, so I guess maybe.
We have to do it right on top of the function. No?
Oh, we do. Oh, I forgot. Where do we have to do it?
Or,
Like up here?
like, no, in our DFS function, on top of our DFS function.
Oh, honestly, I forgot. Do it.
Comments matter.
All right, go for it.
Is there spaces in between?
I don't think so. Because if there's repeated work, I think this should fix it. Unhashable,
Wait, did we change?
unhashable type set. What? What? This is.
Did we change anything? Is that all we changed? I'm gonna remove this just to
Yeah, I
make
think
sure.
cache. I guess I don't understand how cache works. Oh man.
Okay, so it's just a cache. So maybe we just do like a.
What'd you do? What are you changing?
Oh, I just changed the set unhashable type dick. What do you want from me?
Yeah, I have no clue.
how it's like everything's a
Oh, it has to be a tuple because like if because these are stored by reference, so they could change, and then the hash would not be the same. You know how you try to do like let's say unhashable type or list, and you have to make it a tuple. It might not work.
so what they were saying is basically
Do I have a
we can't have
TikTok?
these in our
No, I just be
function
programming.
header.
That's what I think. Dude, I don't know.
Which makes sense. I would assume memorization would say that because usually everything is done in like
So can we just make our own memoization? Like,
yeah.
dude, I'm so pissed that this works and like it's too slow. Wait, what happened? We don't have cash anymore. Oh, we do have cash. Get rid of that. Damn, I need to find a new way to donate because
I still don't
I've got
understand
banned.
how like doing it manually gives you a different answer. Like what is like is it
Yeah,
is
we're
it the
not
way this
removing.
works? I just don't understand
The way what works?
the way discard works.
I think it has something to do with this path thing, how we go through twice. It's like poisoning the table. That's why I figured this would work, but I didn't think. But I know it's so slow.
What's the time complexity doing this?
O of n every time, and
Oh,
this
and
one's
then
also O of n.
yeah, adding separately would be like O of one, right?
Yeah, yeah. That's that's the beauty of doing it outside. What do we do? Like, do we try to like commit to fixing this, or do we like try something new?
We were trying memorization, right? Memorization stuff.
Oh, oh
How do
yeah.
we?
What
How
repeated
do we?
work are we doing? Is the question, I guess. Maybe you should just print like all everything we're calling in DFS and see if we see any like patterns. It's like maybe
The path?
wait, should we do pat? Wait.
Yeah,
Oh,
path.
but doesn't it matter what like the path and what was before
Uh,
it though?
and the current min. So like we know like if we have a current min, that's like because like we don't want to do a path again that we have a min that's lower than our one. So like maybe our uh memorization can tell us if we have a better optimal pace, just return that instead. Yes. Like
Wait, runtime error.
current min.
Oh, all right. Did we get any of the same? Yeah, I see it already. 0, 1, and 2.
Yeah, so we do 0, 3 like so many times. 0, 3, 4, 0, 3, 2. But the my only concern is that
Wait, are those part of different calls? Because you know this is like because
yeah,
it wouldn't be considered the same if it's in a different call from the for loop.
exactly. Exactly. That's that's what I was gonna say. My only concern is that, if we memorize something that's from a different call and return something, that would be incorrect. So we need to like reset it every time, I guess.
Wait, let's do. I'm gonna do like DFS here, and then let's see if we see any duplicates now. Oh, welcome back, software little bro.
Yeah, we still
Zero
see
two
duplicates.
two. Yeah. Oh, wait, which one?
0, 3, 0, 3. Um, does it twice?
0, 3. No, but the other thing's different.
Yeah, which is the minimum. We just want to return the minimum, the one with the minimum path, and say if we have a minimum path that's lower than what we already have, then just return it.
Oh, yeah. Let's do that.
It does 0, 3 so many times too. That's crazy though.
Yeah, so let's have a map, and it just is like path and then the minimum that we found so far. Wait, so what are we, but it's not recomputing the same thing because that's like that means we're already higher. So should we just have a case up here that says like if path and current if the path at current min is like lower than higher than what we have in our map, then just return.
Wait, yeah. So we should only add it to our memorization once we have a complete path towards that thing. And if we have, which is like on line 46 or wherever, no, not necessarily line 46, like 20. Like once we have a complete path, we should be able to somehow capture. Oh yes, the path would be captured within um and our path, but we don't know like at what cost we got it at, right? We
Oh,
would need some way to add that it costed this amount to get here.
yeah, I think this is really where the DP is coming in. How did we end up here? We're doing hard DP problems. It's not what I imagined I was going. Hmm. So what do we really care about? We care about the minimum amount of steps to get to, or edges crossed to get to a certain point. So I think what you were on to something with the path, because the path shows where we're going, and we should just store that in some type of map, right? So we'd have a map at the top.
But we only want to store it when we complete a necessary path, like a complete path. Because if we didn't complete it and then we put like a minimum, and we say that it's a minimum, then we could say we can incorrectly say that the minimum to get to this path is this, but it doesn't actually lead to a successful path.
You gotta show me an example, because like in the first example, like from 1 to 0, the minimum to get from 1 to 0 would be 1, right?
Yes.
And then from 0 to 2, the minimum would be 2, because you have to go starting from 1, you got to go to 2, and then no, you got to starting from 1, you got to go to 0 to get the thing, you got to go to 2. So the answer would be 2, right?
To go to 0 to 2.
Well, 1 to 0 to 2, because it's like continuous.
Yeah, one. So if we start at 1, it would be 2,
All right, peace, brother. Appreciate you popping out.
right? Yeah.
Yeah.
But
So isn't
like
that good?
yeah, that's correct. That's good. But like an example that I'm thinking of, and I'm trying to see if I could replicate it, is that like what if we have a path that goes from one one to 0 to 3, and we put
When I
that as
blow
the
up
minimum
programming,
to get
dude,
to
how the
3.
fuck am I supposed to get my
But
donation
that
box back? Stop
and
scamming, bro.
well,
So I can
the
get them
different one is
donations,
really
buy some
simple in that
groceries.
you know
Nah, I'm playing. I
it
appreciate you
wouldn't
pulling up
happen in
though,
this
bro.
case. So maybe let me try an example two.
Okay.
Um, so like from 0 to 1 to 1 to 4. So like let's say to get to 4, we would have went from 0 to 1 to 2 to 4.
For a cost of 3.
Yeah.
And once we find 0 to 1 to 4, that's a cost of 2. So we update it to that's our new minimum. So now, like,
But we didn't visit all nodes yet, so we go 0 to 2 to 4 to 1 to 2 to 3.
wait. You lost me. What?
Because we got to visit all nodes.
Wait, no. I think, because do you know how like back DP is like you're building like up to the solution? So
Yeah.
what if we just know what's the minimum place to get from one node to another, and we build off of that to get to the next point?
Yeah. That sounds smart.
It's like from 0 to 1, we know that like there's no way, the minimum way to get there is 1. And then with
That's our only way to get there. Yes.
yeah, yeah.
Yes. Minimum node.
And then it's obviously going to go backwards, like from one back to zero. And that's also going to be one. And then that call ends because there's nowhere to go. We go backtrack to the one. And then when it goes to the four or the two, whichever one it picks first, both of those will be the min. But like, so where are we like recomputing stuff? I guess that's the part I'm a
Because
little confused on.
0 to 3, three, a lot of times, not even 3 times. The amount of traces we see 0 to 3 is ridiculous.
Zero to three. Wait, how is that
And I
pop?
don't
Oh,
know.
you're looking at the first example? What are you looking
Yeah,
at? Oh,
yeah, the
okay.
first.
So we
Now
go
let's
in
look at.
zero to three a lot.
Yeah. But we could
Oh,
stick
now you're
to,
on the two.
I guess. Let's see. And we do
Oof.
4 to 2 a lot.
Which one?
Uh, 4 to 2, 4 to 2.
With the cost of what? What's their minimum? I guess it doesn't matter.
Yeah, many different costs. Um, but we do eventually find the optimal cost, but we do it a lot of times before we find it. So like, um,
Is there any way to
we want,
save that? Because like, don't we have to look at the bad ones first or something?
we just want to take whatever we get, but like at some point, like we should start rejecting things if we already found something optimal, you know, that's better than
Yeah.
what we want to go to. But I really think you was really close to something when you were talking about like check the
You know how?
previous one, and
Yeah,
then yeah,
well, you know how we in DP we have that array. What if we had an array of like all the nodes, and then we'll see what's the minimum like cost to get to each one from our starting point. It's like I don't know if you see my cursor on line 20. In the first example, I guess I guess kind of like how Dijkstra's is, but like kinda. So what are they all going to be in default to? I guess like infinity because they're like infinity away, and there's four nodes. So we have an I, and then we have an I, and then for node zero that we started, it's going to put that to zero.
hmm
And when we go from zero to one, we're going to mark that as one because that's like the minimum cost. And then
yeah,
we go to one, and from one, let's say we go to two first. One to two would have a cost zero of two,
two, yeah,
and then like let's
one to
say we're like
four,
yeah, one to four would have also a cost of two,
yeah. So you can mark, yeah,
and then I don't know.
I
Let's
mean
say
one
we're
could
at
also,
four. What happened?
one could also go back to zero, right? What do we
Oh
do about
shit!
that?
Oh, you're right. Wait, do we need to know that?
One can also go back, but it can go back to zero. But we just need to make sure that we don't do it. So if it goes back to zero, the cost to go back to zero is already set to zero. So we wouldn't update that, right?
Yeah, yeah.
Yeah, we just leave it as it is, because
That would
we already have
cost one.
a zero. Yeah,
Yeah, I think that makes perfect sense. And then let's say we're at the four. We say if go four to one would cost one, two, three because we're over crossing an edge twice. But we already see to go to one cost one, so we're not going to update that. And then when we're at the two, we can say two to
okay.
what?
So we had four. We already. What was your algorithm just now? Say it again for me.
I was saying if we're at four and we like, let's say we look through its neighbors and we say to go back to one, that would be like three edges because we had to go zero to one to four back to one. And we already see that we can get to one with a low minimum cost of one, so we don't update it. We check its
Yeah.
next
So
neighbors.
so
Hmm?
the algorithm was 2 plus 1, correct?
Two plus two. What do you mean two plus one?
Because how do we know like the cost would have been to go from 4 to 1 at that case would be exceedingly bigger than what we already have.
Oh, I guess you
Not
have yeah. We start at where we are in the distance array. So like four, which is at two, and then I guess we just add we just add one more. So yeah, the current place plus one more.
did
Shit,
you
I did not mean
accidentally
to do that.
So to get to 1, that would have been 3 from 4. So we're not changing that um, because we already have a minimum cost there, right?
Yeah, and when we get to 2, we just like we could look at 3 and we say 3 is infinity away, but we could just be 1 plus what our current cost is, which is 3.
At 4?
Wait, no. I was thinking while we're at 2. What's
Oh,
at
oh, oh,
2?
yeah.
0, 1, 2.
2. So 2 plus 1, yeah, which will be 3. And then this
But
will
the
be 2
answer's
then.
supposed to return 4, so like there's something not right here. I think it's I don't know. It made so much sense until I got here. So what's the minimum cost to get to 2 is 2 because you go from 0 to 1, 1 to 2, that's 2. Oh, you need to reach all nodes, not just a certain node.
That is true.
Damn. Oh no, man.
Yeah, I really thought I was on something.
I really did too. I was on to absolutely nothing. I don't know, man. This is sad. This is. Do you think fixing line 43 is gonna fix our problems? Oh shit! What's good? What's good?
Line 43.
Ashmit? I remember you from before.
I think we, yeah, I think we need to add a bunch of things to fix line 43 to optimize line 43. It's not that it's wrong, it just needs to be optimized. But bro, I cannot go any longer. I do have some social things I need to attend to. And we should
Honestly, I
definitely
ain't mad because I was getting burnt out too. Fuck. Uh,
we definitely had this tomorrow though. I want to get back to this. I feel like we're there. We're there. Bro.
yeah, it's definitely the most ambitious problem we've ever tried to solve. Uh, that went okay, I guess. I feel like we got thrown into like the fire pit with this one. We have not been practicing DP, and to go to a hard DP problem is like was like a bit of a rush. Dude, I really feel like if we figured out how to add the nodes and remove the nodes like the normal backtracking way, it would have worked. Because we only missing like 2 cases, and it's just this O of N twice. Sad
Yeah,
times.
this part and adding thing is like I still don't fully understand why it works for one and doesn't work for the other, but
I
maybe
suspect it's because the path is like double edged or something. Maybe if we just added the reverse too, we only I don't know. I don't know. We'll figure it out tomorrow.
yes.
But because I'm just gonna be here forever trying to theorize on why the answer's not working. All right,
All
but
right.
all right, peace, man. I'll catch you tomorrow.
Come on.
All right, boys. All right, boys. All right, boys. What the? What are we doing? Yo, it's software dinner. You want to solve something? Oh, W word. W vortex hammer. All right. That did not go as beautifully as I would have liked. Find the minimum time to reach the last room. Nah, bro. Nah, bro. I want to do something easy. We're ending off the day with something easy. Is not solved. Language is Python. Premium content is not premium content. Boom. Remove outer parentheses. Maximum area of hole in a grid. That doesn't sound that fun. I probably could do it, but I'm tired. I want something easy. Sort matrix by diagonals. Build an array with stack operations. I think I tried that and got like Self-dividing numbers. Smallest number with all set bits. That sounds easy. Return the smallest number. Return the smallest number x greater than or equal to n, such that the binary representation of x contains only set bits. A set bit refers to a bit of binary representation of a number that has a value of 1. So it only has ones. Okay. So n is 5. I feel like this is easy. First, I'm taking my 5-minute break. Boys, we're gonna play a quick game, and then we're gonna solve that problem. It doesn't seem that bad. I mean, it is ranked easy. Bro, what is this guy on? I want to be able to castle, so I'm not going to do that. But if I castle, then I lose my other pawn, so I think I can't. Should be able to castle now. Unless he goes rook d1. He does not go rook d1. Beautiful. But am I down on time? He's 20 seconds on me. What? Do you want to draw? I'm drawing. Fuck you. I don't know what to do. One more, one more. This last game, we're back. We're back. Sicilian? What? Did I just get like, did I just get cooked? I think I'm cooked. He just dropped. Yo, you better think fast, brother. mean, you just take my knight. That's over. Whoop. That didn't go too well. All right. All right. Return a number greater than x that is equal to x. Greater than x. I'm in college today. Is my data structures and practicals. My syllabus is till graph. I'm prepared till stack. Oh, brother. I think you got some work to do. I'm thinking like, so how do you check if all the bits are on in a number? Oh, easy. Okay. But good luck, bro. I believe you got this. For I in, why is this so small? Let's make this bigger for the people to see. For I in range, and we start at n, I don't know what number to go to. Nah, we don't need a for loop. We need a while loop. So while x equals n, so while x, we just do if bin, if binary at x dot count 0 equal 0, return x plus equal 1. I think that's literally all you have to do. Oh yeah, let's go, baby. Fist bump. Bro fist. It's really slow. I get it. That's the slow way of doing it. Is there a more efficient way? Um, I think using bin is slow or something. We can use some bitwise operator. Maybe we say if x XOR. Can we XOR it? How do we check if a number has only ones in it? If x, can we do and 0? Wait, and means if both. What? So think about it. And is if both bits are on. Oh shit, software dinner. You still here? If you want to, you could join this one. I totally forgot. My bad, bro. I forgot. So the and is if both bits are on, it'll get on. So if we do and 0, oh yeah, XOR 0. We just do x X or 0? If X or 0 equals X, I think this also works. Nope, that does not work. Oh, duh. Okay, there's a way. How do we do this? So if we have 5, how can we check reliably if 000 has all bits? If we do XOR like 0, so 0, 0. That literally equals 7. But what if we did it? What if we did like 5 XOR? So we have 5, we have 0, we have 1, 1. Oh, and then 0. Oh, the preceding 0. 5 XOR 0 is 5. 1, 1. Isn't this bit literally like the same? So it should be a 1. No. Think. All right, think of this. We need something better. Can we use and? So and is if both bits are the same, it returns 1. Oh, so if x and 0 equals 0, then that's right. What? So 5 is 0. There's a 1 for the ones place, a 0 in the twos place, and then a 1. This is 5, right? Because 1, 2, 4. And I said and 0. And for some reason, this equals 0. Oh, I guess that would be 0. Hmm. Especially and 1. Because this would be represented as 0, 0, 1. Hmm. And 1, maybe. Because this is 7. Like 1, 1, 1. And we say and 1. These would be different. I don't know. How do you check if all the bits inside of a number equal 1? This is not that hard. Yo, I don't know if anybody's watching. Y'all got any hints? I guess my old solution works. I guess. And the fastest solution is just saying place. What is the solution? You get the bin of n and you replace all the zeros with ones. If you have 7, yeah, I don't understand this code. What does this even do? Yeah, I know that converts it to. This just gets the prefix. Replace every 0 bit with a 1 bit. Converts the modified binary string back into an integer. Oh, I guess that's faster. Good for you. Self-dividing numbers. Let's try that. A self-dividing number is a number that is divisible by every single digit it contains. For example, the number 128 is self-dividing number because okay, a self-dividing number is not allowed to contain 0 digits. Given 2 integers left and right, return a list of all self-dividing numbers in arrangement left and right, both inclusive. Okay. So we need a for loop. Okay. Continue. The 0 and list of numbers continue. And then we just need to make some helper. I'll just call it like helper. Self. You can't do that. So define helper, and we just say it takes in like a number. And num equals, you know, array equals list of num, and then for d in array, if num modulo d does not equal 0, return false, return true, and then if helper of num, then we just say res dot pen num. Hey yo, and then return res. I can't spell Boom. Oof. That hurt the soul. An object is not literable. Literable. Oh. Rookie mistake. Rookie mistake. Yeah, you. Yeah. You cannot split a number into a list. You can turn to a string first. There's no typecasting, so I just had to say. Just gonna say. I wrap this into an event D. This should work. There we go. Yippee ki Nice. It's slow. What was the fast solution? Modular arithmetic? Last one. Number goes I, temp equals num. Or temp is greater than 0. R equals temp modulo 10. Oh, so he's getting the last number, so this is the most like right hand number. And if R equals 0, or if no, oh, I love that solution. Yeah, that was smart. Number of changing keys. Fuck it. Can we hit like one? Wait, we have 180, 485. How many problems did we do today? Not that many. You were given a zero index string S typed by a user. Changing a key. Changing a key is defined as using a key different from the last used key. For example, AB has changed. Has a change of key. What? For example, AB has a change of a key. Oh, S does not have a change of key. Return the number of times the user has had a key had to change the key. Modifiers like shift capitals won't be counted in changing the key. If the user types letter A and then uses A is not be counted as changing the key. There's like shift in here. Is that not literally the answer? Oh shit. -1. What? Oh. Mm. It. We need to convert everything into lowercase. I need to rethink this stuff through. So if they give us a string like this, we need to convert everything to lowercase. Char dot was it uppercase, lowercase, char lowercase for RMS. Damn it! I knew it didn't. How do you do a lowercase in Python? How how do you use lowercase in Python? How do you convert a thing to? I think it's like lowercase or something. Strings dot lower. It's you don't need the case. Nice. M M changed to D. Oh. I just did that. All right. What did we do? What did we get done here? Some more easy problems. Subarrays, distinct elements, sum squares one. Okay. Oh, we got a whole grip of easy problems. Given you were given a zero index integer array nums, the distinct count of a subarray of nums is defined as let count of I to j be a subarray of nums consisting of all indices from I to j, such that I is greater than one. And okay, then the number of distinct values is in nums I to j is called distinct count. Return the sum of the squares of the distinct counts of all subarrays. How do you generate all subarrays from an array? If I know how to do this off the top of my head. I guess we just take I by itself. maybe we start off with like we have a for loop, and we have starting with I, so we do I by itself, then I have two, and then I have three, and then yeah, I think that makes sense. Or I range. Probably a two by itself because we want to start off at I. So it starts off in the beginning. And then we want to go. We just do I plus one. Is that how you create a subarray? I don't really know. Let's see. So we have 0 to 1 here. And next it's gonna say, oh no, because we always want. How do you make subarrays? Oh lord. What do you mean nested for loop? I think clearly because they said IJ. And I feel like they should start off at I. Okay. Subarray is just gonna be from I to J, maybe? So it'd be 0 1. 0 1 would get us here. And then it'll go 0 2. Then 0. Will I go 0 3? 0 1. 0 1. 0 2. This only goes to 2. Let's check this out. Oh, sub. Yep, perfect. And we just have to say, this is, we're gonna return the sum of squares. Oh, wait. Return the sum of squares of distinct values of all the subarrays. Distinct values. One, two, three, four, five, six, seven, eight, nine. One, two, three, four, five, six. Okay. I'm a little confused. We have all the when it says distinct values, what do they mean? Return the sum of squares of all distinct counts. Distinct counts. Okay. Stub equals length of set of sub, and then you just say res plus equals count. The second power. Let's go. Another one down the hatch. Is it actually that slow? Am I just all my solutions just ass or something? Result and range like nums. Ox. I don't know why I called it ox. Ox that add nums of j. What? What did he do here? Instead of actually getting the subarray, he just has an ox, and he just goes through and he just adds nums of j. How does this even work? I don't know. Lucky numbers in a matrix. Given an n by n matrix of distinct values, return all lucky numbers in a matrix in any order. A lucky number is an element of the matrix such that the minimum element in its row. Wee woo. What's going on, brother? A lucky number is an element. If no is equal to Max of tricks. I think it's not zip or something. I don't know. The column's a little bit tricky. I think that I don't think this does what I think it does. Double check. Check. Zip at matrix. What, bro? Brian. Oh my god. I'm getting tired. Can't even code properly right now. May I just want to ask you: are you a student? Or are you doing? Are you doing job now? Doing job. Doing job, brother. Yo, I'm actually retarded. What is wrong with me? There is no len of a number, brother. I'm literally just trying to see how matrix works. How zip works on matrix. I forgot. Oh my god. It just returns a zip object? How does that even work? Forgot. How does zip work in Python to get matrix? I forgot how to do this. Okay. Basic idea zip. Zip. Yeah, it gets. Yeah. Oh, you need to turn it into a list. Oh, that was my error. It turns this into a. So this will give me the list. Column equals list of matrix equal to max of column. course we got it wrong. Oh, we never returned anything. Why do I always have the slowest? Yeah, I have no idea what this guy do. The fastest solutions always. Is my shit really that slow? Like actually? Yeah, it's dog shit. Is zipping is really that slow? Recomputing the min many times. Oh, oh, that's the problem. Oh, fuck that. I'm not fixing that shit, man. Did we get one last problem? How many problems do you have to? 1, 2, 3, 4, 5, 6, 7. You're given two non-negative integers, no more than up two, in an operation. So much reading. All right, you're getting two non-negative. No, bro, we did not. We got like 50 out of 58 test cases, and then we failed. I remember you said you wanted to hop on. I'm about to get off soon, but you can join if you want. The wild number one or number two of num one greater than or equal to 2. 2 else 2 minus equal count plus equal 1. Yo, I'm supposed to do something. I didn't do any C++ today. There's no way, bro. Time limit exceeded? I guess it never ran. Num1 minus equals nums2. Not, not equal to 0? Aren't they changing? I'm literally. That's a little weird, bro. That's a little weird. While num1 1 equals num1 minus num2. Num2 equals 2 minus. Why would this not work? It's like a little strange. Oh, and brother, and fuck, I'm retarded. Oh yeah. Why is everyone so much faster than me? That is literally what I did. Hold up. You're lying. All right, there we go. It's like decently fast now. Lucky numbers. Faulty keyboard. 490. Can we finish the day on 490 problems? Who knows? Your laptop keyboard is faulty, and whenever you type a character I on it, it reverses the string that you have written. Typing other characters wherever you expect it. You're given a zero index string S, and you type each character of S using a keyboard, return the final string. S. Okay, what? It reverses the string you have written. You are given a string S and you type each character of S using your faulty keyboard. After typing the first character, text on the screen. TR. You hit I, so it should be RTS and then NG. Okay. Ugh. Oh, brother. L equal to. We finished the day off strong. Let's go, baby. Um, that's a beautiful way to end the day. Beautiful way to end the day.